This is the first video in a set of 4 videos that we're going to look at during this ACT prep course that are going to help you do better on the math part of the ACT. As you can see, there are 8 topics in this particular video, so feel free to skip around, pause, and go back as needed. So let's get started. Alright, so now we're going to talk about vocabulary and general number rules. Some of these things might seem kind of easy, but they are good to talk about regardless. Integers are whole numbers and their negatives, so you can see the set right there. Odd numbers, one thing I wanted to point out are negatives are included. So when you think of odd, you think 1, 3, 5, 7, 9, but also negative 1, negative 3. Same thing goes for even numbers, 2, 4, 6, 8, but also negative 2, negative 4, negative 6. These are all even numbers. Consecutive integers come up sometimes on the ACT. And what they mean by consecutive integers, or what the question is asking you to determine, typically are numbers that come in an order. So 1, 2, 3, 4, 111, 112, 113, 114. If you don't know what the numbers are, typically writing them as n plus 1, n plus 2, and n plus 3 is going to be the way to go. Consecutive odd or even integers sometimes will pop up. This is kind of a thinking question where you have to understand that if your first number is n, the next number, because odd and even integers skip a digit, you know that the next number has to be n plus 2, the next one would be n plus 4. So for instance, if the first number is 1, this would be 1 plus 2 or 3. This would be 1 plus 4 or 5. This would be 1 plus 6 or 7. So number lines come up kind of a lot. You got to know how to work with the number line, negative, positive. So a question that you might see is what is the midpoint between 2 points on a number line? So looking at this particular picture, you got R and W. What's the midpoint of RW? So since R is at -6 and W is at 8, this is simply an average question. So when I talk about average between 2 numbers, I would say -6 plus 8 divided by 2. In this case, that's 2 over 2, which is 1, which you can see is smack dab in the middle of R and W, so that would be the midpoint on the number line. The last 2 concepts we're going to talk about are rational numbers and irrational numbers. Rational numbers are the numbers that you work with most often. They have decimals that end or decimals that repeat. So integers, fractions are all rational. Irrational numbers are decimals that never end and never repeat. So when a question asks you to work with irrational numbers, what you typically want to do is use square roots that do not come out pretty. So for instance, root 2, root 5, root 10. Any square root that's not a number will work. So when I'm working with irrational numbers, I typically like to work with those as a guideline. Pi is also irrational. Next, we're going to talk about rules for exponents and roots. And when you see questions that involve these rules, they should be slam dunks as long as you know the rules here. So let's just get started looking at these. The first one is when you multiply two exponential terms of the same base, you add the exponents. So when I say a to the n times a to the m, you add the exponents. So in practice, what this would look like, if I took x squared times x to the third, that would be x to the 2 plus 3, which comes out at x to the 5th. All right. The next thing we're looking at is when I have power to a power. Typically when the numbers are next to each other, what you want to do is multiply the numbers. So in this case, I'm looking at example x to the 2 to the third. So what that would look like is x to the 2 times 3 or x to the 6. So you can see the difference between the first and the second rule, and differentiating between those is going to be key to doing problems correctly. The next rule involves when you divide 2 numbers that have the same base, you subtract their exponents. So for instance, x to the 6 divided by x to the second would be x to the 6 minus 2 or x to the 4th. Alright, the next rule, number 4 here, is when you take anything to the 0 power. Okay, that's going to be something that you just got to know. Memorize it, know it. If you have your calculator, you can do it, but anything to the 0 is 1. So for instance, looking at 5 to the 0, that's 1. 10.2 to the 0, that's 1 as well. Looking at number 5, a to the first is a. So any number to the first power is itself. So 5 to the first is 5. 10.2 to the first is not 5. It's 10.2. So next rule that I'm looking at is when you have 2 things multiplied inside parentheses to a power outside, you have to make sure you distribute that power. So this a times b to the n becomes a to the n, b to the n. So an example would look like if I took xy squared to the third, you have to make sure you distribute that 3. So it becomes x to the third, and then y to the second to the third, you multiply the powers, which makes y to the 6th. That's a concept that comes up quite a bit on the ACT actually, so know that one. Number 7 through 10 we're going to look at here involve radicals. So when I'm looking at radicals, there's just some general things you got to remember. When I multiply 2 radicals, you can put them under the same radical. So root a times root b becomes root ab. So for instance, root 2 times root 3 can become root 6. All right, number 8 the idea with number 8 and 7 is that you keep numbers outside with numbers outside and the numbers under the radical with the numbers under the radical. So for instance, 5 root 2 times 3 root 3 would be 15 root 6. So when you multiply 5 and 3, you get 15, and root 2 and root 3 is root 6. All right, so you can see that property comes up quite a bit. Number 9 here, if you have a square root of a over b, you can separate the square root to be the square root of a over the square root of b. This happens to help you in questions like root 4 over 9. You could separate that as root 4 over root 9, which can be separated again as root 4 is 2, root 9 is 3. So that helps you out with that particular question. Number 10 is when you have a radical on the bottom. One of the rules you see down here is a root times itself equals the number. So when I take root 2 times root 2, that equals 2. When I take root a times root a, that equals a. So in this particular problem, if I take b over root a, if I multiply top and bottom by root a, then I'm not really changing anything because root a over root a is just 1, but it does help me to cancel out the radical from the bottom. So looking at an example, if I take 6 over root 2, you can multiply top and bottom by root 2, which will give me 6 root 2 over 2, which I can now reduce 6 over 2 and simplify this all the way down to be 3 radical 2. Another question that pops up are least common multiple questions. My tip for you is to work backward from the answers. Look at the answers and see if the numbers can go into the given answers. What's the smallest one that all the numbers can go into? But just to talk about what least common multiple is, you're trying to find the smallest number that all 4 of these numbers will go into. So I always start with the biggest number, because if the biggest one can't go in, then it's not the least common multiple. So I look at 15. 2 can't go into 15, so 15's out. All right, let's start looking at another multiple of 15. I don't even care about the multiples of 2, 3, and 9 because 15's not going to be able to go into those all the time. So I'm going to look at the biggest one. So 15, the next thing that 15 goes into is 30. 2 can go in, 3 can go in, 9 cannot, so 30 is not it. So you keep going like this. 45, 2 cannot go in. 60, 9 cannot go in. 75, 2 cannot go in. Until you get down to 90. And 90 they all can go into. So 15, 9, 3, and 2 can all divide into 90 evenly. So that makes 90 the least common multiple. Dealing with fractions is a skill that you're going to need to have on the ACT. General tips here at the top, if you look at 3 and 3/8, if you want to know what that is a mixed fraction, meaning like improper fraction with the bigger number on top, you can multiply 3 and 8 and get 24. So really 3 is 24/8, and then you would add that to 3. So basically 3 is 24/8 plus 3/8. So basically what you're doing when you multiply 3 and 8 is getting 24/8, and then you're adding it to 3/8. So altogether, the improper fraction version of 3 and 3/8 is 27/8. So that's just something to think about. And then again, if you want to go from improper fraction to mixed fraction, you can divide 15 by 4 and see how much is left over. So 15 divided by 4 is actually 3 with 3 left over. So really what that means, if I'm looking at this, is I got 3 with 3 left over. So at 3 makes 12, so 12 over 4 is 3, so then I got 3 left over, so it ends up being 3 and 3/4. If that's problematic, practice some more of those if you want to look at some of those. Or again, ask your ACT prep teacher to help you out. Alright, so what some questions look like dealing with fractions. General tips here. I would change them to decimals. You guys have calculators that you can use. So feel free to change the fraction parts of any number to decimals. So when I look at this particular question, 3 and 3/5, I could change to 3.6. 2 and 2/3, I could change to 2.6, repeating. And then this becomes a very simple equation to solve. You just subtract 2.6 repeating from both sides. And then in your calculator, the tip that I'm giving over here is you do math, enter, enter to change a decimal to a fraction. With this particular problem, since 6 never ends, I would just write a bunch of 6s. I know that's kind of silly to say, but if I go 3.6 minus 2.66666 and just keep writing as many 6s as you can, then you change it to a fraction, you're going to find the answer. In this case is 14/15. So general tip is change your fractions to decimals, and make sure you know how to do that because you don't want to mess that part up. So just make sure you change the fraction part of a mixed number into a decimal. That'll help you out. All right, the next thing we're going to talk about is when you have a fraction within an equation, how to deal with that. What you want to do is make sure you multiply out by the least common multiple. if there's only one fraction, that is the bottom number. So in this case, there are two fractions, so I have to think about the least common multiple. So in this case, the least common multiple of the denominators is 6. And so if I multiply everything by 6, every term in this particular problem by 6, what you end up with is 6 times 2 over 3, or 12 over 3x, 6 times 1 over 6, and then 3 times 6 is 18. So this just becomes 4x plus 1 equals 18. You subtract 1. And this doesn't come out pretty, but this is how you work with fractions. So you divide by 4, and you finish this question, x equals 17/4. So looking at this, finding slope questions, the big thing you got to make sure you recognize is that slope-intercept form basically tells you the slope. Whatever number is with the x is the slope. The other number is called your y-intercept. That's the number that goes, it's where the graph crosses the y-axis, the vertical axis. So looking at this first question, and these questions pop up from time to time in the ACT, it says, what is the slope of the line represented by the equation 6y minus 14x equals 5? This should be easy. Again, another slam dunk question as long as you know how to do it. You add 14 to both sides, and the whole trick is to get y by itself. So what I have, I'm going to put that 14x in front of the 5. All right, don't put it on the other side. That's not what slope-intercept form looks like. It looks like y equals something x plus some number. And at this point, you divide by 6. So to get y by itself, all I had to do was subtract, or add, in this case, 14x, and then divide everything by 6. So now 14 over 6 reduces to 7 over 3. And then 5 over 6 is the y-intercept. But really all I cared about in this question was what the slope was. So in this particular question, the answer would be 7/3. Not 7/3 x. The slope is the number that is with the x. It's the rise over the run. And it's given by the fact that I know slope-intercept form up here tells me the slope. So if I put an equation in that form, I will get the slope. If a question asks you to find the slope between 2 points, there's a simple formula for that. You guys have seen it, I'm sure. It's y2 minus y1 over x2 minus x1. So in this particular question, if I call this x1 y1 and this x2 y2, it's simply negative 2 minus 5. So m equals negative 2 minus 5 over 8 minus 3. And it's just making sure you follow the formula correctly. So in this case, I get negative 7/5, and that would be the slope there. The ACT definitely requires you to know how to FOIL and factor. The way I teach multiplying, so in this particular question I'm looking at, it says for all x, 3x plus 1 squared equals. Typical mistake students want to do is distribute the 2, the power of 2 into there. You don't distribute. When you take 3x plus 1 squared, you times it by itself. So this becomes a FOIL question. There are 2 ways with which you can do this. The first one is what you call the FOIL method, where you multiply the first things. 3x times 3x is 9x squared. The inner, and then the last. So 1 times 1 is 1. So you put it all together, you combine your like terms, 3x and 3x is 6x plus 1, and that would be what you get there. The box method is when you make a box, a 2x2 box, you put the 2 things that you're multiplying along the outside of the box, and then you just multiply across. So I take like 3x and 3x, and that gives me my 9x squared. I take your 3x and 1, you cross those, you get 3x. Do the same thing for 3x and 1 down here, and 1 and 1, and then you combine your like terms, and you should get the exact same answer that we got when we FOILed. Alright, so 2 methods to FOIL. Both are going to get you to the correct answer. But again, the trick to this problem is making sure that you know when you see 3x plus 1 squared that you don't distribute the 2. That's a common error that students will make. For factoring, there's 2 ways you can go about factoring as well. When I look at this particular question, what is the sum of the 2 solutions of the equation, x squared plus x minus 12? This is a factoring question that requires you to do a little step at the end. But the first thing we talk about is MAF. And MAF requires you to find what multiplies to a number and adds to another number. So the first thing, m, is given by taking a times c, or the first times the last. In this case is negative 12. The a is always your b value. Okay, so that would be, in this case, just 1. So now I'm asked, what is multiplies to negative 12 but adds to 1? In this case, it's 4 and negative 3. When there's no number here in front of the x, your work is pretty much done at this point. Your x value equals the opposite of f. So my x values are negative 4 and 3. To show you why, I mean, once you find your factors, you call it x plus 4, x minus 3 equals 0, and now your zero products property says either this equals 0 or that equals 0. When I set x plus 4 equal to 0, I get x equal to negative 4. When I set x minus 3 equal to 0, I get x equal to 3, which is why I get these two solutions. My answer to the question that was asked, however, is what is the sum of the two solutions? So what I do is just simply add negative 4 plus 3, and you get negative 1. If you're not a fan of MAF and you learn the box method, you still start by doing MAF. So you're going to get negative 12, 1, and then 4 and negative 3. What you do at this point is you put x squared in here, you put your 4x and your 3x here, and you put your negative 12 here. I'm just showing the steps for doing this simply because when you have no number, again, you probably wouldn't want to do the box. You don't necessarily need to do the box where you factor everything out. But just to show you the steps of doing the box method, we'll go through it. At this point, you factor out the rows and columns. So you factor out the GCF out of x squared and 4x. In this case is x. The GCF out of negative 3x and negative 12 is negative 3. The GCF out of x to the second and negative 3x again is x. And then the GCF out of 4x and negative 12 is 4. And you always take the first term. If the first term that you're taking out is negative, you pull that out as negative. So like this one was positive, so I pulled it out as positive, which makes my factors here x plus 4, x minus 3, and then we can finish the question very similar to how we finished the last one. So two methods for factoring, both of them get you to the answer. And in this case, the trick again wasn't just find the answer, it was find the sum of the answers. So again, you got to answer the question that the problems are asking, which is why the ACT can be tricky, but make sure you're just taking your time and reading through. The next thing we're going to talk about are transformations. The big thing with transformations is know your parent functions, first off. So here's a list of some important parent functions. Looking at these, I got the constant function, your linear function. Absolute value is a v. Got to know what absolute value looks like. Your step function, your greatest integer function. X to the second, x to the third, square root of x. This one shows up not very often, but it is a parent function, so it's the cube root of x. This is an exponential graph, so something to the x power. This is a log or ln graph, so it's log based something of x. If you're in algebra 2, you haven't seen that, but that's going to pop up. This is a 1 over x graph. All right. This is a variation of a 1 over x graph where the top has a higher degree than the bottom. And then you got your sine, cosine, and tangent graphs. So what that looks like here. If you look at a sine graph, the big thing is that the period of a sine graph, which is one wavelength, is 2 pi. So once again, a period is a wavelength. So there's questions on the ACT that pop up quite a bit that just ask you how long is the period of this particular graph. And basically all you got to do is look at the graph and then see how long one wave is. The same goes for cos. The period of a cos graph is again 2 pi. And again, the period is one wavelength. Tangent have a different period. Tangent periods are pi. And you can see that if I look at one tangent piece, the period of a tangent curve is pi. And so there's not really a wavelength for tangent, but it still has a period. So once again, know what period means. It simply means wavelength. So if the question asks me what the period of this particular function is, you just count how big is one wavelength. Next, we're just going to give a quick tutorial on transformations. What does changing the equation do to the graph is kind of key. So we're going to take root x, for instance. We could do this with any of the parent functions you saw on the previous slide, but looking at root x kind of helps because you can see everything that you could possibly do to it. So looking at this, if I add or subtract something outside, it shifts the graph up and down. So for instance, if I look at root x, the parent graph, which I should probably show what that looks like, the parent graph of root x starts at 0, 0, and kind of goes up in that manner. So when I look at a graph here, where I take root x plus 3, well, it still looks exactly the same, but in starting at 0, 0, like root x does, it shifts up 3. Looking at the next one, if I add or subtract something inside, it does opposite of the sign. So if you subtract 4, what you do is you shift the graph right 4. So you see this graph starts at 4 instead of starting at 0, 0. So once again, you always start with the parent graph and you do whatever the equation says. So there's a -4 inside, shifts the graph to the right 4. If you multiply the root x by something outside, it changes the value of the outputs. So for instance, if you take the parent graph, which is right here, this is what the parent graph looks like. It has points at 1, 1, and 4, 2. Well, the 2 root x graph is going to have points at 1, 2, because 1 times 2 is 2, and then it's going to have a point at 4, 4, because you take and multiply the outputs. So what that does is it multiplies the outputs, and it makes your graph stretch vertically. So when you multiply by the outside, that's what would happen. When you multiply a graph by a -1 in front, it flips the graph from going up, like the parent graph did, to going down. So it flips the graph over the x-axis. Alright. When you multiply by a negative inside, it flips the graph about the y-axis. So the normal root x goes this way, root negative x goes the other direction, flips the inputs to being negative. So this is just a quick tutorial on simple transformations, knowing what adding and subtracting and putting a negative inside and outside and putting a number in front does to the graph of an equation. The last thing we're going to talk about in this video are percent problems. The first two things we're going to talk about are how to change a percent to a decimal and how to change a decimal to percent. These two skills should be just basic things that you shouldn't have to think too much about. If I want to change a percent to a decimal and I'm not too sure how to do it, divide by 100. A lot of teachers tell you move the decimal place 2 to the left, but if there's no decimal, sometimes you're confused about that. Just use your calculator. Take 95 divided by 100, you will get 0.95. If you take 115%, take 115 divided by 100, you get 1.15. 4 divided by 100 gives you 0.04. If I'm going to change a decimal to a percent, go backwards. If I'm looking at a decimal 2.3, what is that as a percent? That's 230%. And again, the trick is multiply by 100. You can move the decimal place 2 to the right now, and you see like, oh, that's 230. But I think multiplying by 100, simplifies some of that for you, especially if you're not sure where the decimal point is. So then 0.10 corresponds to 10%. 0.002, again, if you move the decimal place 2 to the right, it becomes 0.2%, or you can multiply by 100 the same. All right, simple percent problems, some teachers will teach it different. I just like to look at the words. Every time I see of, that means multiply. Every time I see is, that means equals. And every time you see like a number or what, that's talking about an unknown, that's talking about x. So when I set up this equation, this one can be kind of tricky too, because there's kind of two questions in this particular problem. It says if 115% of a number is 460, what is 75% of the number? So 115%, that's one thing that you might get tripped up on. 115% is 1.15 of a number, so times some unknown x is equals 460. So solving for x, I divide by 1.15. So x ends up equaling 400. I'm not done at this point. One of the choices is probably 400. The next question is, what is 75% of the number? So new question, what is 75% of the number? So what is equal. So what is my x? So new equation, what is 75%, 0.75 of the number that we found was 400. So of would be times 400. So really just think about some keywords when you're working with percents. Of means multiply. What or a number is your unknown typically, and then your is your equals. So 75% of 400 is 300. My answer to this question is 300. Don't stop short and just write 400. You might know exactly what to do, but mess up because you stop short of answering the correct question, which is one of the tricks to the ACT, which we'll talk about.